remember to record the lecture today. Okay. Now we're going to move on to the actual content for L'Hopital's rule. So we're gonna kind of introduce it step by step though. So let's first start with the do now. Can I get someone to volunteer what they thought for the first question? Just really quick how they did the first do now, the limit as x approaches infinity of, yeah. Samantha, you want to come off mute?
For the first question, since I think what it was, since e to the x power is dominant over x, I got infinity. Mm-hmm. That's right?
Yep, that's exactly right. So there is a hierarchy of dominance. I'm not sure if I'm including every single type of function here, but it's like x to the x is more dominant than a to the x, and e to the x is like the same type of thing. And then what else it would be? It'd be like x squared, x is larger than root x, like radical x is larger than natural log of x, if I remember correctly. So if you want to write that down, just refresh your memory. So basically, the way I look at for n behavior functions, right? This is an n behavior limit. We have to first find the dominant terms in the numerator and denominator. Well, the dominant terms are pretty easy because there's only one term. And then e to the x is more dominant. So I'm going to say it's going to infinity, it's larger, right, in the numerator, and then smaller in the denominator, right? Because e to the x that's going to infinity goes way up at 5 of x increases linearly. Right, so e to the x is obviously going to dominate. Since it's much larger over a much smaller number, that's going to infinity. So we have infinity. Can someone share what they did for the second problem? Aaron?
So the first thing I did was that I factored out the 2x squared minus 32.
Gotcha. How did you factor that?
I factored out the 2. So I got 2 times x squared minus 16 over.
And then what was your next step?
And then I factored the x squared minus 16 and got 2 times x minus 4 times x plus 4.
Awesome. Yeah.
Minus 4.
Yeah, so that's exactly right. I think this fraction is actually slightly confusing because you have to take like 2 separate steps. So first you factor out the 2, and then this is like a perfect square. I forget what it's exactly called, but it's like the same pattern. It's x minus 4 times x plus 4. You'll encounter it pretty frequently. And then the x minus 4's cancel out. So really what you're left with is 2 times x plus 4. Now with this limit, you can just plug in 4, right? And then you're going to get 2 times 4 plus 4, which is equal to 2 times 8, which is equal to 16. Awesome. So thank you, Aaron, for doing that. Okay. Now we're going to look at these limits as if we had no idea what we're doing. So I'm going to pretend to look at the limits as if I have no idea what I'm doing. These are pretty easy, but let's say for the first one, let's say I didn't know anything about n behavior limits. The limit as x is approaching infinity for e to the 4x over 5x. We all know that's pretty easy because we're looking at the hierarchy of dominance. But if I didn't know what I was doing, I would say, okay, well, the numerator is going to, like e to the 4x, if it's going to infinity, it'd be infinity, right? It's going to infinity. The denominator, 5x, well, that's also going to infinity. So my answer would look like this. This is, again, if I have no idea what I'm doing. If I don't know what I'm doing. So you can rewrite this and say, like, if I forgot how to solve for these type of limits, this is me kind of just like expressing, moving into the lesson. But so like honestly, if you don't want to write this part down because it'd be kind of dumb in your notes, you don't have to. But I would say it's important to, we're going to discuss why the infinity over infinity is important. But let's say for number 2, the limit as x approaches 4. Let's say I didn't realize I had to factor anything. I just plugged in 4. Okay, so I'm plugging in 4. 2 times 4 squared minus 32 over 4 minus 4. So that's equal to 2 times 4 squared, which is 2 times 16, right? So 2 times 16 minus 32 over 0. 2 times 16 is equal to 32. So 32 minus 32 over 0. And that's equal to 0 over 0. So I have an infinity over infinity and 0 over 0. Well, those obviously aren't very good answers, but that's what would happen if I had no idea what I was doing. And this is where L'Hopital's rule can come help us. So let us now, here I'll give 15 seconds for people to copy down something if they want to copy down something from this page. So we're going to look at L'Hopital's rule now, which says that this applies the limit as x approaches a for f of x over g of x is equal to the limit as x approaches a for the derivative of f of x over the derivative of g prime of x. So basically, if we find f prime of x and g prime of x for both the numerator and the denominator, the limit should be equal to the same thing, which is very interesting. So I would like for everyone to copy this down. I'm going to give maybe 15 more seconds for that. And then we're going to, 15 more seconds. This is ultimately L'Hopital's rule. I'll say this is the first part of L'Hopital's rule. And also it is pronounced L'Hopital if people want to be technically correct. There's probably someone in the world who's going to make fun of you if you say like La Hospital or something, which I don't know. I feel like that's what it looks like, La Hospital, but it's L'Hopital. Anyway, so we have this, right? We're told this is true only if we have one of the following indeterminate forms. So what does this mean? This means when we evaluate our limit initially, if we have one of these forms, our answer comes out to this, then we can use L'Hopital's rule. And that's why I did the previous step. Because if you notice, 0 over 0 is one of these forms, infinity over infinity is one of these forms. For our do now problems, if we have no idea what we're doing, notice we're going to get infinity over infinity, and then 0 over 0. So these limits are ideal candidates if we don't know how to factor, right? Like if we don't know how to factor, if we don't know hierarchy of dominance, these limits are ideal candidates for us to actually apply L'Hopital's rule. So it's almost like another strategy that we could use if we don't know how to solve that. So again, L'Hopital's rule applies only if this is true, if we have one of the following indeterminate forms. Cool. So let us work on the do now problems. Again, I'm going to take us through them. So this is kind of our third time working through these do now problems. I'm going to give everyone like 15 more seconds or so to like recopy down the problems for like probably the third time or second time. Okay, so I'm going to rewrite L'Hopital's rule here. So it'd be the limit as x approaches infinity of f of x. Well, I substituted infinity for a here because we're looking at infinity, but for f of x over g of x is equal to the limit as x approaches infinity of f prime of x over g prime of x. In this case, we already know this is an indeterminate form. It's infinity over infinity. So let's apply L'Hopital's rule. So if we derive e to the 4x, right? Let's say the limit as x approaches infinity, e to the 4x over 5x would be equal then in that case, as the limit x approaches infinity, for the derivative of e to the 4x. Remember now we have to, well, let's just say, what's the derivative of e to the x? Can someone share what the derivative of e to the x would be in the chat, please? Thanks, Aaron. Yep, that is an identity we should remember. So it's e to the x. So let's just rewrite that, e to the 4x. However, we will notice that there is a 4x, right? So that means we have to apply chain rule. So we're going to multiply by the derivative of 4x. So it'd be multiplied by 4. Now, the denominator is the derivative of 5x. We all know by power rule, that's just 5. So we're really going to have the limit, I'm just going to rewrite that, the limit as x approaches infinity of 4e to the 4x. Remember, this is chain rule. Over 5. Now, this is kind of easier to think about. We don't have anything in the denominator, and x is going to infinity. So really, we just have 4/5 e to the 4x, and it's going to infinity. Well, then our answer is obviously going to be infinity. The limit is going to be infinity, right? Because x is going to infinity. The only term is in the denominator, and e to the 4x is increasing. So our answer is infinity. And let's compare that to what we got initially on our do now when we solved it with hierarchy of dominance. It's also infinity. Great, so that tells us L'Hopital's rule is working for this problem. I'm going to give everyone 10 seconds or so to copy down this work. Aram asked me to clarify how it's infinity again. So it's just infinity in this case if we don't know hierarchy of dominance, just because, well, e to the x, right, is going to increase like exponentially, right? And we don't even have to compare it to anything in the denominator. There's no like function in the denominator. So it's like, it's almost like any function as x approaches infinity. Like if the numerator was just even x, and it's just a linear function, as x approaches infinity, we know that the value is going to go to infinity. In this case, it's e to the 4x. It's more obvious even that it's going to just keep on increasing infinitely. So again, this is infinity. Now, I would like for now everyone to take 3 minutes or so to apply L'Hopital's rule to the second problem. The same concept that we did up here, and apply it to the second problem. And I'm going to give everyone 3 minutes, and then I'm going to call on some volunteers to share. So please begin now. 2 more minutes or so. And then if anyone has an answer and like went through the whole process of L'Hopital's rule, please type your name in chat. Awesome. I'm already getting responses from Aaliyah and Aram. Thank you for that. Give another minute and a half or so. Cool. So I would like to see a few more names in chat, because I think this problem is pretty like standard for L'Hopital's rule. Okay, awesome. I'm getting a couple more now. Cool. Thank you, Alexandria. Okay, so I might call on a few people for this problem just to take us through individual steps. Kayla, would you be able to come off mute and just like, how did you start the problem?
So I started out by like factoring out 2 from 2x squared minus 32.
Okay, okay, gotcha. You can do that. Damani, do you have thoughts on whether like you would take that first step or not? Thanks for sharing, Kayla.
Wait, what did you say?
Kayla said she factored out the 2 as her first step.
Yeah.
So is that what you also did?
Mm-hmm.
Okay, is there anyone who did something different in the chat? You can just really quickly say me or, okay, Christian, you did something different. What did you do?
I just found the derivative of the whole thing without like factoring.
Gotcha. Yeah, so that would probably be the first step that we want to take. Because remember, we're just looking at L'Hopital's rule now, right? We're just doing this whole thing. Actually, I'm not sure if you guys can see me highlighting that, but we're taking a function, x approaches infinity in this case, for f of x over g of x, and we know that it equals the limit as x approaches infinity for f prime of x over g prime of x. So we can just find the derivative of the numerator and denominator and then solve. Now, we can factor first and then find the derivative, but that actually probably makes it more confusing because it's like, how do you factor this? It's like easier to multiply it out, but that's neither here nor there. Basically, it's a completely unnecessary step. So the first thing we can do, Christian, do you want to continue on, and how did you factor out, like, or how did you derive the top, like the numerator and the denominator?
For 2x squared, I got 4x, and then I just crossed out the negative 32, and then for the bottom,
Gotcha.
I got x. Well, x is going to be 1, so I put 1, and then I got rid of the 4, the negative 4. So I got
awesome.
4x over 1, and then I substituted the 4 in, and I got 16.
Okay, cool. So you took us through the whole thing there. So I'm just going to write that down really quickly. So starting This is just the original problem, 32x minus 4. And now this is equal to the limit as x approaches infinity for the derivative of f, so f prime of x. So we're going to just find the derivative of 2x squared minus 32. Well, what is that? How do I find the derivative of this? Well, it's very easy. I can just do power rule. I don't even need to factor out anything, right? I'm just finding the derivative. Previously, like if we want to solve it algebraically, we can factor it out and we don't find the derivative. But in this case, if I'm using L'Hopital's, I just derive it. So it'd be 2x squared, bring down the 2, right? Subtract 1 from the exponent, so it'd be 4x. Negative 32, that's just a number, so that disappears. X, what's the derivative of x? It's 1. The derivative of negative 4 is 0, so that disappears. So I'm getting this. These two are equal to each other. And we know this is true because, again, L'Hopital's. I know if anyone else showed this to me, like before today, right? If I didn't know L'Hopital's, they just showed me that these two are equal to each other, I'd be like, why? How do I know that they're equal to each other? That just seems so random. But we know that they're equal to each other because we know this rule, that if we take the derivative of the top and the bottom, they're going to be equal to each other. Again, if it's part of an indeterminate form. I guess it all goes back to this. This indeterminate form is 0 over 0, so we know L'Hopital's rule applies. But that's not that important right now. Oh, sorry, I've been writing infinity. My bad. This is 4. For this problem, this is 4. Here, I'm gonna give everyone like 15 seconds to correct that because people probably copy that down. Yeah, we're going to 4. Okay, cool. And then Christian, thank you for taking us all the way through. Here, you can just plug in 4, right? Because, I mean, the denominator isn't a 0 or anything, so just plug in 4. 4 times 4 over 1, that's not relevant, so we get 16. Now, hopefully here, I'll give 10 more seconds, so in case people need to copy stuff down still. Okay, so now let's compare this whole page. We use L'Hopital's rule. The first page, we got, so for our answers, we use L'Hopital's rule, we got infinity and 16. For the first page, we employed our other techniques that we know. Like for our do now, we employed end behavior and algebraic manipulation, and we also got infinity and 16. Cool, so that, I mean, that's great news for us because that's telling us that we're doing something right, right? We got the same exact answers. That's telling us that L'Hopital's rule works with how we solve limits with our other strategies and stuff. And I will go back to this point again because I need to emphasize this. L'Hopital's rule only applies if our original limit is one of these indeterminate forms. And I will also mention this form and this form. I think it's worth copying all these down, but 0 over 0, infinity over infinity are by far the most common forms we're gonna encounter. So we already did a problem where you plug in the numbers and you get a 0 over 0, and then it's going to infinity, you get an infinity over infinity, and it's like really weird and all this stuff. Those are by far the most common type of problems we're gonna be applying L'Hopital's to. To be honest, I haven't even done problem, like, I don't even know for some like infinity minus infinity. Actually, I think you could come up with an example problem like that, but some of these are just really confusing. So I would say it's worth trying to recognize these. I don't even know if it's worth trying to remember, like memorize these. The vast majority of the problems, again, are going to be 0 over 0 or infinity over infinity. So, okay, I'll give like 5 more seconds. Okay, so L'Hopital's is actually very useful because you know how the do now functions? Luckily, we were able, if we didn't know L'Hopital's, we could do it with algebraic manipulation or end behavior, right? So we have 2 strategies to solve it. Mercy asked a question saying that 0 to the 0 is equals 1. So does this mean this works when the limit results in 1, 2? She's saying that 0 to the 0 is equal to 1. So I guess this does mean that. To be honest, I'm really not even familiar. Also, I know anything to the 0 power is equal to 1, but I'm not sure if 0 to the 0 is an exception. Honestly, I'm not really sure. I would just say, like, if you want, just memorize these indeterminate forms. So if you ever encounter it, you know to apply L'Hopital's. So I don't know, I couldn't exactly answer your question. If any of you guys have like more developed thoughts on that and you want to share, you can chat me. But to be honest, I'm not really sure. But anyway, so continuing with my last point, for like this limit, right? The limit as t approaches 0, we couldn't even use any other techniques. Like we can't, t is in the denominator. That's really messed up because anytime we plug in t, we're gonna get a 0 in the denominator. Well, that's not good. And then can you factor out t and cancel? I mean, you can't really do that. This obviously isn't an end behavior limit. Basically, our only method in this case is applying L'Hopital's. So I would like everyone to take 30 seconds right now to tell me which indeterminate form this problem would be in. So it's going to fit into one of these forms, right? Now, which indeterminate form would this problem fit in? Well, I got one answer from Aram. And remember, we have to check this, like just really quickly at the beginning, just to make sure that it is a problem that we can apply L'Hopital's to. Awesome. Thank you, Daniel. Thank you, Ansel. So Ansel, can you come off mute and just share how you got the indeterminate form you put and like what your answer is, I guess?
I got 0 over 0 because I just plugged in 0 for t and 3 times 0 is 0 and anything raised to the 0 power is 1. So that's 1 minus 1 for the numerator, which is 0. And then it says right there, t equals 0. So that's going to be 0 over 0.
Yep, exactly right. Thank you for that. So you took us through the whole thing. So we can just plug in 0, right? Substitute in 0. 3 times 0 minus 1 over 0, right? And that's e times 3 to the 0, so it's e to the 0 minus 1 over 0 equal to e to the 0 is 1, so 1 minus 1 over 0 is equal to 0 over 0. So that's our indeterminate form. Let me give everyone like a couple seconds to write that down. But basically, that tells us that, cool, we can apply L'Hopital's, which is, we're very thankful for that because the other strategies that I would use, we can't really use. Cool. Now, once we do that, I would like everyone to take 2 minutes to just solve the problem. So use L'Hopital's and tell us what the limit is. One thing, when we're deriving e to the 3t, do not forget to do chain rule. So again, 2 minutes and I'll come back. Once you get your answer, you can just send it in the chat. Thank you, Samantha. Awesome. And that is the right answer, so good job. Thank you, Aaron. I'm going to give just one more minute because we are kind of nearing the end of our class. I would like to see a few more answers in chat. Remember, we're just finding the derivative of the top and the bottom, and then doing the same exact process, same exact limit. Okay, so I am getting some different answers for this. For the sake of time, cool. For the sake of time, Samantha, would you be able to come off chat and come off of mute and kind of take me through each step? So we start off with this, right? And then we derive the top and bottom. So how did you do that step?
Okay, I set that equal to limit. I set that equal to the limit of 3e to the power of 3t over 1 as the limit approaches 0. And then from that, I just simplified it to 3e to the power of 3t. And then when I plugged in 0 into for t, I got 3 because, you know, the power of anything that's 0 is 1 and 3 times 1 is 3. So.
Gotcha. 3 to the 0 equals 3 times 1 equals 3. Yeah, so our answer for this is 3. Now, I think what is most confusing for people is probably this step. This is basically the L'Hopital step, right? We're deriving the top and the bottom. So the derivative of e to the 3t, right? So f of x, let's say, is e to the 3t. Then f prime of x, again, we have to do power rule. So the derivative of e to the x or e to the t is going to be the same thing. So we're going to have e to the 3t now, right? But there's a function within this function. There's the 3t part. So we need to also derive 3t. So we're going to find the derivative of 3t, which is 3. So we're going to get 3e to the 3t. So that's how you get the numerator as 3e to the 3t. Now you might be kind of confused because you're like, well, how come for e to the x, nothing like that happens? Well, it actually does. So let's say f of x is equal to e to the x. This is our identity, right? What's really going on is we have our identity, e to the x, right? The derivative of e to the x is e to the x. And then we're also, let's say we can do a mini chain rule, e to the x, and then we're multiplying by the derivative of x. Well, that's just 1. So that's why at the end of the day, it's still e to the x. We did do a chain rule, right? So that's just to clarify chain rule for you guys. But yeah. We have 2 minutes left, 1 minute left. So I'm going to let you guys go here. Just remember to complete the exit ticket, turn in a picture of your class notes, and then please start working on the homework packet. The homework packet, I feel like there's a couple problems that might be kind of challenging. So if you have any questions, feel free to email me or text me, and then definitely consult the video that I uploaded. Yeah, and that is it. So thank you all. I will see you all tomorrow morning for your shortened day. So I hope you guys are excited for that. And yeah, thanks. I can also stay behind after class if people have questions. Hi, Mateen, how you doing?